Okay, so we proceed for the next step, compensated and uncompensated. So based on this information, we need to divide which one is compensated, which one is uncompensated. We put uncompensated first lah. Compensated. This is compensated. The uncompensated for sure belong to this one lah, because this system without observer control, with the L kan, with the L. So this is uncompensated. This one is uncompensated. For the compensated, which means that we need the system to perform 5% overshoot. The overshoot 5%, and also the peak time equal to 1 second. So for same thing with the pole placement controller, we need to find the damping ratio and damping frequency, and then after that we need to apply to the S square plus 2 zeta omega n s plus omega n power of 2 equal to 0. That for the compensated part. Okay. Can you help me to find this value? The damping ratio and damping frequency. This formula also given in the appendix. Make sure you know how to use it. To get the damping ratio, the formula negative ln percentage overshoot divided by 100 divided by pi square plus ln power of 2 percentage overshoot divided by 100. For the omega n, for the TP, so this one 0.69 omega n. Huh? 4.23. The damping ratio is 0.69. The damping frequency is 4.23 radian per second. This is unit. The damping ratio you don't have any unit, but for the damping frequency you have unit, radian per second. Frequency because frequency kan. Okay. Same. Okay. So when you replace to this equation for the compensated part, what is the answer you get? S square plus with 2 multiply with 0.69 multiply with the 4.23 S plus 4.23 power of 2. Then you obtain 4.23 apa? Which one? So you got 4.34 So we change to 4.34 4.34 So this one will be 4.34 and then should be 4.34. Was it 5.999? S plus with, was it 19? Huh? Oh, 18. 18 49. Okay. So it means that our target, we want to convert this uncompensated system to perform like this. So that's our target. So how we want to modify our uncompensated system become like this we just need to apply L to the system. Okay. So if you know that, if you still remember, this is our formula for the observer controller. So we just need to put E dot equal to your A matrix. This is your A matrix, which is, we just use this formula. E dot equal to your A matrix, -5, -4, 0 and 1, minus with your L, multiply with your C. Your C is 1 and 0. Your C is 1 and 0. Multiply with the, everything multiply with the E lah. Okay. So this is your formula to apply the observer controller. The formula is E dot equal to A minus LC multiply the E. So this is your E dot. This is your A matrix. This is for your L. And then this is your C. Okay. If you still remember, your K form is K1, K2, K3 multiplied with the X and S1, S2, S3. This is your Kx. However, because this is observer, everything will be transposed. So your K something like this. So your L will be, how many L do you need? L1 and L2. So what you need, you just need to remember the pole placement controller. The pole placement controller is a diagonal, horizontal. For the K, for the observer, your L will be vertical. Okay. So if you settle this one, you get E dot. And then this is -5, -4, 0 and 1 minus with, if you multiply with together, L1 multiply with 1, you get, because this is 2 by 1 and then this is 1 by 2, finally you will get 2 by 2 matrix. Okay, this is your, so L1 multiply with 1, you get L1. L2 multiply with 1, you get L2. L1 multiply with 0, you get 0. L2 multiply with 0, 0. And then this is your E. If you solve this one, finally you get negative -5 minus L1, you get besar tak ada. Okay. -5 minus L1, you get -5 plus L1. -4 minus L2, you get 4 plus L2. 1 minus 0, you get 0 minus 0. So E dot, this is your E. I told you that inside here is your new A. So this is your new A. Okay, so whatever, yes. 80.81. So this one 80.84. 18.84. So This supposed to be acting for 84. Okay. Okay. So what we did so far, from the information of everything, we already get the compensated system by using S square plus 2 zeta omega n and so on. So the characteristic equation of the compensated system is this one. Okay. Based on the uncompensated system, we apply to the formula, and then this is your new A, and finally you get your new A. So when we want to convert the L to find the L value, if this compensated system you have the characteristic equation, this one also you need to convert to the characteristic equation. Then we can compare. So that's why we need to find this new A. By using this new A, you can get the characteristic equation. Then you can compare the value. Okay. If you still remember that to get the characteristic equation, this is the formula kan, Si minus A. The determinant of Si minus A. So in order to get the characteristic equation of the uncompensated system, you need to find what is your new A. Then you can apply the formula of the characteristic equation of the Si minus A. This also is given in the appendix. So what is the formula for the appendix? What is the formula for the uncompensated system? What is the formula for the characteristic equation? The formula for the characteristic equation given in appendix is Si minus A. So this is your new A. You need to find this one. Then you can apply Si minus A, the determinant lah. Okay. So you need to find Si minus A. Si minus A first. So this is your S. Since this is 2 by 2 matrix, your identity will be 2 by 2 also. Minus what is your new A? This one lah. Negative 5 plus L1. Negative 4 plus L2. 1 and 0. And then you solve it. S0, 0, S minus negative 5 plus L1, negative 4 plus L2, 1, 0. And you solve it. S minus this one, you get S plus 5 plus L1. 0 minus and minus, you got positive 4 plus L2. 0 minus 1, you get negative 1. S minus 0, you get S. This is Si minus A. Then you need to find the determinant. Si minus A. Use 2T formula. 2T formula, you choose any row or column you like. I use this one. So you have S plus 5 plus L1. And then here will be negative 1. And then I close S plus 5 L1 at the horizontal row and column part. The rest is S. I close negative 1 at the row and column. Only left is 4 plus L2. Okay. And then after that, remember the sign starting with positive and negative. So you just apply sign positive and negative. Finally, you get everything multiply S square plus negative, negative, positive 4 plus L2 equal to 0. So finally, you can conclude that the Si minus A for the uncompensated system is S square plus 5 plus L1 S plus with 4 plus L2 equal to 0. So this is the characteristic equation. Okay? Alright. So finally, you just compare lah. S with S power of 0 with S power of 0 lah. Then you get the L value. Finish. Same thing kan? Same thing for the pole placement controller. So finally, so this one compensated done, uncompensated done. So now we want to find the L values. Is it we need to find multiply with the third pole? Why we not need to? Because in pole placement controller, ada example kan, we need to multiply with the third pole. Why in this case we not need to multiply with the third pole? Yeah, because they're already same lah. So let's say if the question, the uncompensated system is third order kan? Let's say this is 3 by 3. So this one you need to multiply with the third pole. Okay? Because since the uncompensated system is second order system, and then your compensated system you get second orders also. So is it comparable? Yes, not need to multiply with the third pole. Okay, you just need to multiply with the third pole for the compensated system if and only if the uncompensated system is third order and more. Then you need to multiply with the third or fourth or fifth pole, something like that. Is it clear? Okay, since they are comparable, so you just compare between them. 5 plus L1 equal to 5.99. So L1 equal to 0.99. Is it correct? Kan? 4 plus L2 equal to 18.84. So L2 equal to 14.484. So this is the answer. Okay?